In the previous video, what we did for simple harmonic motion was we were able to build the equation of motion or the displacement. And so this time, what if we were given the displacement? Okay, let's see if we can dissect that. So we have an object that moves in simple harmonic motion, described by d equals 3 cos of pi t, where t is measured in seconds and d in inches. We want to find the maximum displacement, the frequency, and the time required for one cycle. All right, so this is actually a pretty easy sort of problem. Noticing that the coefficient is 3, that's the amplitude. And so the maximum displacement is going to be the absolute value of A in this case, which is the absolute value of 3, which is just going to be 3, okay? And since it's measured in inches, the maximum displacement will be 3 inches. So for the frequency, frequency is going to be equal to our omega over 2 pi. So we go back up here and we see the frequency right here, omega over 2 pi. In this case, omega is going to be pi. Okay, so it's whatever the coefficient of t is. So we see omega equals pi. And since frequency is omega over 2 pi, right, that's going to mean that our frequency is going to be pi over 2 pi, which is equal to 1/2, right? And that's going to be in, it doesn't necessarily say in seconds. There it is, okay? So 1/2 second is going to be the frequency, okay? And then the time required for one cycle, okay? Well, that would be the period, and the period is just the reciprocal of the frequency, okay? So that would just be 1 over 1/2, okay, which just turns into 2 seconds, right? So that's actually pretty easy. Just going through identifying A and omega, and we're done with it. We have another one, D equals -5 sine of pi thirds t. We're looking for the maximum displacement, the frequency, and the cycle. Okay, so in this case, lowercase letter a is -5, and so the absolute value of -5 is going to be +5, and it's again in inches. All right, so that's the maximum displacement. For letter B, for the frequency, remember it's omega over 2 pi. Well, in this case, omega is pi thirds. Okay, so that's going to be pi over 3 divided by 2 pi, which is the same as saying pi over 3 times 1 over 2 pi. Pi's are going to cancel out, and it's going to be 1/6 of a second. Okay, is going to be the frequency. All right? And then finally, all we have to do is just take the reciprocal of that. Okay, so for our cycle, which is going to be the period, okay, that's going to be equal to 1 over our frequency, which is 1 over 1/6, or that's going to be 6 seconds. Okay, so these problems are really pretty basic, just making sure we understand how to dissect or unpack these displacement formulas. Okay, so that's it for our applications. Okay, so hopefully we've gone through, we've seen a lot of various applications. Some of them use the right triangles, some of them use these trigonometric functions.